What's up, Not.Just developers? Welcome back to a new tutorial, and today I have prepared something very special for you. Today, we're gonna build an AI movie recommendation system using React Native and Supabase Vector. What we're gonna do is a very similar system how Netflix recommendation system is working, or HBO Max, or Disney, and so on. We're gonna focus on two main features. The first one is recommending similar movies, and this can be seen basically based on a movie. We can recommend similar movies to that one based on the text and the way we categorize them. Then, using the next feature that is very interesting is the semantic search. And this one will allow us to, based on a user prompt that is very human readable, like, I don't know, let's say in this situation, if you're asking it a movie for the first date, the system that we're gonna build will understand what do you mean by the question that you are asking, by the prompt that you are giving, and based on that and having all the trained data on our database, it will go ahead and find the best matching movies for the specific prompt. We're not gonna leave everything in the CLI. We're gonna put it together in a easy to use mobile application to be able to visualize everything. And the general goal of this tutorial is to help you understand how you can work with AI vectors, with embeddings, in order to be able to implement these kind of systems for any situations. Basically, it's not only about movies. It's going to help you understand how you can generate embeddings, how you can find similar items, how you can build your knowledge database based on what you already have, and build an AI system that knows the data or knows the content of your application and is able to answer questions based on it. So in a way, you're building your own ChatGPT, but this is to be clear, this is not a ChatGPT wrapper. We're not going to use ChatGPT. We're going to train our own data and generate our own embeddings. The tech stack for this tutorial is going to be React Native and Expo on the front end, but this is just the client side. So basically you can connect from anything, like from Next.js, from a web application, mobile, and so on. The juicy part, the meat of this tutorial is going to be on the backend side. And there we are using Supabase. And the most interesting part is the Supabase Vector, which is the product that will allow us to store vectors of our text embeddings that will power our AI recommendation system. And this is going to be done in a vector database connected directly with, stored directly in Postgres. So we're going to be able to store, we're going to be able to query like similar items and a lot more. So very excited about this one. Thank you very much, Supabase, for sponsoring this video. They invited me for their content storm, specifically for AI content, and I couldn't say no because this is so valuable. And yeah, it was very, very easy to prepare for it, and I'm pretty sure you'll love it. So let's get started. All right, so before we actually get started, here are the things that you're gonna need. The step-by-step guide on our website. You can access it at in the description below. We're gonna leave the link. I can paste it in the chat as well. And there you will also find the asset bundle with some data sets for movies that I have prepared for you. So let's go ahead and open this URL. And open it somewhere here, put it in the code mode. Maybe I should do it here. Just like that. And here is the step-by-step guide that you need to follow along this tutorial. The best way to learn is to actually implement it yourself, and this is what will help you do that. So go ahead and download the asset bundle. This will, as I said, contain some data that you need, and maybe also some source code that we will need. And yeah, let's get started. I want to say hello everyone who is joining us live. Let me know where are you joining us from and if you're excited about this one, because I'm Really excited, and I think we should get started because we have quite a few things to do today. Starting with a data set. For this tutorial, I found a data set with basically 45,000 movies from the movie lens, and this data set contains a file here, movie metadata, with the data about movies. So if we look at the columns, it contains information like the genre, the URL, the ID, for example, the title. This is very important for us. The overview, which is actually the description of a movie, and the overview is very important for us because we are going to use it to train our knowledge database to be able to recommend similar movies. So where is it? Column should be, yeah. What else? Like title, the voting, like how much vote does it have, and so on. So you can download this one, but this is not required because I already processed, cleaned a bit, and only selected the most popular 2,000 or 2,500 movies. So in the dummy data, in the asset bundle, you're gonna find, give me just 1 second to find it as well. Yeah, here is the asset bundle. So what you should see is the movies CSV. You can have a look at it by opening it in Visual Studio Code. And here are all our movies with their, I only left the important columns that we need, like title, tagline, overview, and something about the popularity. Anyway, we're gonna need that in a moment, but now let's continue with our guide, and the next step is to set up our Supabase project. So as I said, for the backend, we're gonna use Supabase. They offer a Postgres database out of the box for every project that you create, and we're gonna use Supabase to store the data, the information about the movies that we're gonna display in our application. You can create an account for free, and you can also create 2 projects for free under the free tier. I'm gonna connect with my GitHub account, and from our dashboard, let's go ahead and create our new project. I'm gonna give it a name, for example, AI movies, a database password, yes, I'm using a very simple one with ABC. Will it allow me to do that? I think no. Recommend me a database password. So I'm gonna take a suggested one from here. I'm gonna copy it, create a new project, and I'm gonna save it somewhere. Hopefully I'm not gonna forget where I saved it. Now, after we are doing this, we will see that our project is being initialized. Our database is being created for us behind the scenes, and probably in a couple of seconds that should be finished. How many hours will this be? This is a very good question. I always say like this is going to be like 1 or 2 hours, and after that we end up with 4 hours, but I don't think it's going to be more than 3 hours. From 2 to 3 hours, it should be good. And also depending on how many features or extra features you want at the end. Will it be working with Expo Router? Yes, we're going to use Expo Router, but as I said, the client side is not the focus. Like the React Native is not the focus of this tutorial. And we're going to use Expo Router to be able to navigate from 2 screens, from the list of movies to the details of a movie. Hello, Sunny from New Zealand. How are you doing? Hello, Chiza from Kenya, from Somali. Hello, Oliver. All right, so as we can see, our project has finished initializing. Is it or no? Let's see. Setting up project. No, I think it's still initializing. Yeah. Let's wait a couple of seconds more. But while we are waiting for this thing, I actually have a, where is it? Give me just 1 second. Yes, while we are waiting for that database to be initialized, I have a very small favor for you guys. If you're watching this and if you're enjoying what we are doing here on notjust.dev channel, I would really ask you to consider subscribing to the channel. We have set a huge milestone for this year to achieve 100,000 subscribers, and we are very close to it. We are at 83 right now, and there is only 17 more. So if you can consider subscribing, that would mean a lot to us. And yeah, I know that's possible because most of you, like 98.8% of people watching our tutorials are not subscribed to the channel. So it literally takes you 2 seconds to do that, and it will mean a lot for us. Thank you very much. And let's check if our project has finished. Yes, we see the welcome to your project. That means that it finished installing. Now, what we have to do is go ahead and create a table. For that, let's go to the table editor. And as I said, every Supabase project comes with a Postgres SQL database. And we can go ahead and here create a new table. I really like that we can create them visually, so we don't have to write a lot of SQL. So for the name is going to be movies. Description, you can leave it empty. I will leave all the options as it is. And here under the columns, let's go ahead and have a look at the columns from the guide. So what we need there is the IMDb ID. Let's choose that IMDb ID. The type of this is going to be a text. And actually, let me bring this one here, just not to have to go back and forth so many times. Let me find the columns. Yes. So after IMDb, we don't want to discard. We need to add more columns. And to make sure that you see them properly, I will do it like this. Okay, so we're also going to have a title of a movie, which is also going to be a text. So let's find text. What else? The overview is the description of a movie, so that's also a text. Besides that, we're also going to have what? The popularity. And this is going to be a float 8. It's going to be a float 8. After that, what do we have? A poster path. Yeah, I expected the database, the data set that we are using to have some posters, because when you have posters in the user interface, it looks much better. But this poster path, they are almost all of them are outdated. Some of them are still working. So, and then we're not going to use it, but just add it to have it in the database. We need all of these fields in the exact, like with the exact same names to be able to import the data in the next step. So make sure you don't have any typos and you select the proper data types for all the fields that we have to define. So we have two more. Vote average. The vote average is going to be a float 4, and the vote count is going to be an int 8. So let me double check if we have everything. ID created add. Then I think this is incorrect. It should be IMDb, not BD. IMDb ID. This, I think we define it as varchar, but should work with text as well. But let's make sure it's how it was in our guide. Title text, overview text, popularity float, poster path text, tagline, text, vote average float, vote count, integer. Okay, we are ready to save our table, and this will create our table with Postgres. It's adding all the columns. What have I missed so far? Not much. We are just setting up our Supabase project, and that's the only thing that you need to do so far. Set up the Supabase project and create a table movies with the columns that you can find, of course, in the guide. And once that is done, we don't have any data here, but we see the button import data via CSV. So let's select that one, and we're gonna use the CSV file that I provided through the asset bundle. So here it is. You can download, of course, from the link in the description and in the guide. And after unzipping the asset bundle, you're gonna find the movie CSV. This movie CSV, let's drag it here, contains only the titles that match the titles of our database. And it contains the first 2,500 movies, like the most popular ones. Also, yeah, after doing that, you're gonna see some items here, some data, and we can press import data if you don't have any errors. If you have some typos in the column names, you're gonna see some errors here. So just go back, update that table and the column names to match the ones from movies CSV, and after that, try to import it again. As they're saying, this dataset is also contains movies before 2017. So if you're gonna search some new movies, you're not gonna find them. But it's like a great dataset to train and to build like AI applications. All right, so what do we have right now? We have a table in our database with almost 2,500 records of movies, Toy Story, Jumanji, Hit, and so on. What do they have here and we are interested in is in the title. The overview is basically a short description of a movie. We're gonna use this overview to build our knowledge dataset and to train our AI model with it. Also, the poster path, as I said, like it's quite outdated and most of them are not, you're not able to display them. And the tagline is maybe something that we can display in the user interface. Okay, so now that we have our Supabase project, we have created the movies table. We imported a list of movies there. What we can do is we can move to our client side, set up our basic application that will be able to query the movies from the database, have that ready, and only then we're gonna get into the AI, into the embeddings, and so on. So there is one more step before we get into the AI, but stay with me, it's gonna be worth it. So, also, make sure to follow the guide here. It has all of this information. The next step is to generate and to build our Expo application. We're going to do that with the Create Expo application command line. So that means that we don't actually need anything in the environment other than Node.js. This is the easiest way to build React Native applications. So if you haven't done this before, basically you don't need anything in the environment other than notJust, which I think you already have. So let me actually go into some projects, YouTube, Netflix recommendation, and what do we have here? Yes, I think this one is good. So let's go ahead and using npx create expo app. I'm gonna add latest to make sure that we are selecting the latest version of Create Expo application if we don't have that one already. And let's give it a name, AI movies, and -t to be able to select a template. I would like to go with a TypeScript template. We're not gonna focus too much on the TypeScript. If we have time, I'm gonna show you how we can add auto-generated Supabase types for our database, but yeah, that's not the point of this tutorial. And at the same time, I'm not going with tabs because it comes with a lot of, the template is too bloated, like it has too many things. And if you are just getting started, it might confuse you more than help you. So I'm gonna start with a blank one. We're gonna set up everything ourselves because the application that we're gonna build is not that complicated. It will have a list of movies, as you can see here, and the movie details page that will display a list of recommended movies based on that one. So now that our Expo project is ready, let's go ahead and open it in Visual Studio Code AI Movies. I'm gonna close the terminal because we can open it already in Visual Studio Code for managing it easier. And let's do that by going to terminal at the top. Let's open a new terminal. And before we jump into the code, I will like to start our development server and run our application to see what do we already have. So by running npm start, we will start the Metro server from where we can run our project on different devices and clients. The easiest way here is to go ahead and use the Expo Go application on your physical device. It's available both on iOS and Android, and simply scan this QR code with your phone. I have an emulator, so I'm gonna press I here to open on iOS simulator in order for you to also be able to see our result. Something like that. And yeah, that's what you should see. A simple text in the middle, open up TSX to start working on your application. Okay, let's listen to what it says to us and let's open app.tsx from our root folder. And here is basically our very small initial application. If you change this text to hello world, save it if you don't have autosave enabled, you should see our application automatically reloading to show the new data here. Perfect. Let me see what's our next step. And our next step is to link our Expo project with Supabase. You can see more details about that following this URL in Supabase documentation. But what we are interested in is running this command npx supabase link to basically link our local or our React Native side, our client side, with our Supabase. Let's go ahead and paste this command, npx supabase link, but as you can see, we need a variable. We need the project reference. How do we get that? Let's go to our Supabase dashboard. And somewhere here under project settings, we should see the reference ID under general settings. So let's copy this one. Let's paste it here. And let's press enter. What we cannot read what? Cannot read open Supabase. Have you, should I do Supabase init first? I think so. Let's go ahead and do npx supabase init first. We can do yes because we are using VS Code. And what do we have here? We have Supabase with very empty everything. Now we can go ahead and do the link command to link our local Supabase project with our remote Supabase that we created through the dashboard. Enter your database password. This is where our database password is going to help us. So if you don't have, if you forgot it, and if you don't have a database password saved, You can easily change the password through the project settings, database, and here you can reset database password and generate a new one. That's easy to do. Now what we see is that our project has been linked correctly, and now what we can do is pull that database schema from our dashboard, from the project we created in the Supabase dashboard, to pull it locally. To do that, we're gonna run npx Supabase npx Supabase db pull. And this will, basically cannot detect Docker. For that we need that Docker running, but for that we need Docker running, and that will allow us to run our project locally. And for more information, you can go to Supabase local development. And here is an explanation how you can set up to develop with Supabase locally. I'm gonna leave this in the comments. And now after our Docker with the Supabase is running, we can do npx Supabase database pull. Now I'm thinking if you actually need this for the following tutorial. Because if you don't have the Supabase set up locally, which is not very hard, but you need like Docker and you need just to download the images. It's not that complicated. You just need Docker, and after you do Docker init and Docker start, it automatically downloads what it needs. But I think you're also going to be able to follow along the tutorial even if you don't have Supabase set up locally. We're gonna just do the code, publish it, and try it in the dashboard. Update the remote migration history table. Yes, we can do that. And it finished pulling the database. And now to check like what happened is we can open the Supabase project, and here under migrations, you'll be able to see a file, an SQL file that will have our movies database. So this is simply saying like, how can we set up the database the same way as we set it up here from the user interface, how we can set it up programmatically using SQL. So everything is done for us, and we can close everything. And we can also do git add, git commit, link Supabase, and git, I don't have git push yet, but this step is finished for us. The next step is going to be to connect from our React Native application to Supabase. For that, we need to create a client, and we also need some dependencies. So let's go ahead in the Supabase client here and copy the install command that installs the Supabase JS client and some other dependencies that we will need. Let's copy this one in our terminal, and let's install the Supabase JS client. While we're waiting for this to happen, we're gonna go ahead and create the source directory. And in the source directory, let's create another one called lib, where we will keep all the code related to like external libraries. In this lib, I want to create a file called supabase.js, or let's do it ts, where we will set up our Supabase client. From the documentation of Supabase, if you open it here, you're gonna see how easy it is to set up the Supabase client. So we can copy the code from this part, initializing a React Native application and the Supabase TS. Let's get this code. And what it does, it creates a client based on our URL and the API key. Let's go ahead and see how to find the Supabase URL. And we're gonna do that from the dashboard, also from the project settings. And under the API here, first of all, we're gonna find the URL of a project. Let's copy this one and paste it for our Supabase URL. And for the anonymous key, this is the one that we are interested in, the project API keys. And this key is safe to use in browser or in client-side applications because we have like row level security on our database, and we will be able to prevent people having this key or having only this key to be able to query something that they shouldn't have access to. But anyway, here is our Supabase. We created the client. Everything is good. Now using this Supabase client, we can already start querying our database. So let's see how we can do that. The first step is going to be to fetch movies from our table that we have created. From the user interface, there is also, like if we go to the movies table here under table editor, hope I didn't break it. Yeah, everything is fine. There is a nice little feature in Supabase. If you go to a table, you can open this tab API, and it will show you how you can use Supabase to query informations. What I'm interested in is read rows. So this shows us how we can read movies, all the rows from movies in our application. Let's go ahead and open app.tsx, and instead of executing this code where I'm gonna copy this code, and instead of putting it here, which will also work, let's start with this way. We're gonna have to import the Supabase from the client that we just created, this Supabase client. Now let's go ahead and do console log error to see if there is any error, and console log movies to see the movies. We're gonna open back the developer console and see what we received back from the Supabase. I'm gonna objects are not valid. Why is that happening? If I comment this out, does it still, did I make any typos here? Application. Let me see, maybe I should close the other servers and see what's up with this error. Would this work with Flutter as a client? Yes, that would work. Actually, I'm wondering if you should check if Supabase has a Flutter client, like client library. What did I do here? Application. I think it has something to do with this code workspace. If I simply return null from here, that basically means that we're not rendering anything. So reload. What's up? I am very confused. npm start, maybe clear, to clear the cache. And maybe I can close this one, but for some reason I cannot do that. Okay. Now I see. For some reason, yeah, my application function became async when I imported this function await Supabase. So that's why I was receiving that issue, because functional components cannot be async. Anyway, and also I did that just to simplify a little bit the things, but actually the way we are supposed to query the movies is not in the body of our function, because this will be called every time we re-render the application. In fact, we should call this in a use effect that will only be executed when we mount the application. So to fetch them only once. And to do that, we're gonna define a use effect with empty dependency array. Here we can define a function called fetch movies that we can define it as async. And inside this fetch movies that we will call right away, we're going to, inside the fetch movies function body, we're gonna do this Supabase thing. So let's console log right away here and uncomment the import of Supabase. Now if I do a reload, we should see null for the error and an empty array for the movies. There is no error, but at the same time there is no movies. Why is that happening? That is happening because of the policies of our table. By default, if I put add a table, we see that we have enabled row level security, which means that the way the security is managed, like who is authorized to do what operations, is managed by table policies. So let's go ahead, and by default, no one is allowed to do anything, not read, not update, not insert, and so on. To allow users to perform some operations, we're gonna go to the movies table, and let's press here view policies. By default, no policy created, so let's create a new policy. We can use the get started quickly, and there is the first one, enable read access to everyone. For the sake of this tutorial, this is going to be very good for us. It will allow anyone to be able to read movies. Let's press save policy. And after this is done, we can go back to our terminal. We can refresh the project to query the movies again. And we see already a lot of them. What we can do is, in the guide, I showed you how we can display the movies in a better format using JSON.stringify. We pass their movies. The second parameter is null, and the third one is 2. And this way, we're going to see them a little bit better formatted. But at the same time, there are a lot of movies queried. What we can do is specify how many do we want to select. So we can specify the range to be from the item with number 0, with index 0 until 25. And this way, we will only query 25 movies here. Now it's better. If you do C and then reload, you're gonna see only 25 movies here. Perfect. So what do we do with these movies? Let's go ahead and save them in a state variable, because we are gonna use them to render on the screen, on the user interface. So let's create the movies, set movies state using the useState hook. Initially it's going to be an empty array, and after we fetch the movies, we can check here. First of all, if there is an error, or maybe, yeah, let's say if movies is defined, then we can set them in state. Now, what we should do is render them on the screen. How can we do that? Well, we need a flat list from React Native. So let's import a flat list. And under this text, or instead of this text, because we don't need the text, we can use flat list. And the data for the flat list is going to be our movies and their render item. I will start with showing you at least something. For example, rendering the title of the movie like this. And we should already see a list of titles, like 25 movies from our database. In order to display them, to have a better user interface, what we have to do is create a separate component that will render one of these movie items. Let's go ahead in our source folder and create our components folder, component. And here let's create the movie item.tsx. The code for movie item you can find in the guide. Here it is, display movies. So let's copy this one from here. And it will receive the item, the movie item, it will receive the index, and will simply render the title and the tagline. Let's go ahead in our app.tsx. Let's import movie item from our source components movie item. And instead of all of these functions that we have here in the render item of a flat list, we can simply send there the movie item itself. It's not yet very, it doesn't look very good just because of the way our root container in app.tsx is styled. Let's remove the align items and justify content from here. And now they will look a little bit better. And we can also change the color of our app.tsx. Let me see where we have it, the color. It was a dark gray like this for the background. That's already looking better. And in order to, as you can see, the first item on the screen is actually displayed behind the notch. To solve this issue, we can import the safe area view from React Native and wrap it around our flat list. Safe area view, and we close it after we finish the flat list. Now the flat list will be displayed in a safe area view, which means that it will not go below the notch. So now we can scroll and all the items will be here on the screen. Yes, 26 items, because we are looking for, from 0 to 25. If you want to query more, you can do that here. And yes, this is going to be all the movies in the list. All right, so yes, so far we have this list of items. That's perfect for us. It's going to help us when opening the application. It's going to show us some movies. Later on, we're going to have like the search on top that will be the semantic search powered by the artificial intelligence. And also another type of recommendation that we will implement in this application is going to be similar movies. So for example, if you go to Toy Story and you liked it, below it you want to see a couple of other movies that are similar to this one that you just watched. So for that reason, we're gonna need the detail screen of a movie where we will be able to display the recommendations. So let me go ahead and do git add, git commit -m movie list. And in order to have a separate screen, what we will do is we will set up Expo router to have basic navigation system with two screens. One is going to be a list of movies, and the second one is going to be the movie details. I'm going to make sure to provide the source code for the user interface so that you can move faster if you're interested in that. And it's also going to be put in the asset bundle. Now let's follow the setup Expo router. Let's open the getting started guide from the documentation of Expo router. And here, where? Yeah, not in the quick start, but in the manual installation. Let's follow some of the steps that we have to do to set up Expo router. So we're going to start from the second step, install dependencies, and I'm going to copy the npx expo install Expo router and the other dependencies that we need here. Let's go back in our project and execute this. Then we need to set up the entry point to point to the Expo router, and this is in our package.json. So go to package.json. You're gonna see the main here. Let's remove this one, and let's paste the main with Expo router /entry. Now, following this one, we need to specify the scheme in our app config. This is for deep links, but we're not gonna need it. But let's make sure to add it under the app.json. Somewhere after the slug, we can add the scheme, and you can provide a custom scheme like, I don't know, AI movies. Again, we're not gonna need it, but let's do it to make sure everything works. If you want to support web, you can install that here. We are not gonna focus on the web. And the last step is in the babel.config. We need to add this plugins line with Expo router. So let's copy it from here. Let's open it in our project. And after the presets, let's add the plugins with Expo router. I think that should be everything. Yes. And that should be everything in order to set everything up. But the way Expo router is working is it's a file-based navigation system, and all the files in the app directory will become screens. So that means that we need to define this app directory. So we're gonna create a new folder in the source called app. This is very important with a name because that's how Expo router understands where we keep our screens. And for the home screen, let's go ahead and drag and drop our app.tsx under the application, move it there, update the imports, and rename it to index.tsx. The index.tsx is the home screen. It's no longer the app.js that we had before. The home screen is the index.tsx from the app directory. Now let's go ahead and restart our server. And this time, make sure to add the clear using -- clear to clean the Metro bundler to make sure everything is running clean. Let's press I to open it on iOS. And in a moment, we should see our list of movies on the home screen. All right, we already see something. It doesn't look good at the top and the bottom, but we will adjust that later. The good thing is that we have the screen and using Expo router. Now having this Expo router set up, we can go ahead and create one more file for the details of a movie. So a new screen in Expo Router is created by simply creating a new file in our app directory. And I'm going to use a very specific syntax to Expo Router with square parentheses to add a dynamic path parameter. We're going to see how that helps us in a moment. I'm going to generate a simple component here called movie details. And yeah, that's a simple component exported from our ID.tsx. And the next question is, how can we navigate to this page? And when we should do that? We want to navigate to this page when we press on one of these movie items in the list. So let's open movie item here. And we're going to wrap the whole component in a component called link that is imported from Expo Router. And this way we can link, and when the user presses on this one, we want to redirect somewhere. Pay attention where we import the link from. The link expects the href, and the href should be, for example, ABC, let's say, /ABC. And also, I'm going to provide the asChild property here in order to let the child pressable handle the press events. Now, if I'm going to press on one of these items, nothing happens, but if I'm going to refresh the page and do that again, we are redirected to the movie details page. Not sure if we can go back here, but if you're interested to go back, we can simply add the header from the stack navigation on top. And to do that, we're going to create the layout, the root layout file in our application, layout.tsx. And we can simply do export. Where is it? Let's define it as root layout as a functional component that will simply export the stack component imported from Expo Router. And this way, we are defining that, hey, all of the pages in the application, they should be managed inside a stack navigator. Let's make sure to export a root layout here at the end as default, export default. And just like that, we have the header at the top coming from the stack navigator. We can go back here and we are landed on the index page. Perfect. What's up with these square brackets and ID, and why do we need it? This is the dynamic parameter from the path, from the URL that we are navigating to. And this way we will be able to identify what movie do we want to render. To get the value of this dynamic parameter, we can use the hook called use local search params. And the name of a variable is going to match the name that we provided here in the file between the square brackets. So if I'm going to display the ID here after the movie details, you're going to see now ABC to any movie that we are redirecting to. Why? Because in the movie item, that's what we have here in the path. We hard-coded the ABC here. If instead of that, we're going to add the actual movie ID using a dynamic part like this. If I'm going to go here, I need to refresh to take this to take an effect. If I'm going to go to the first one, we see movie details 1. If I'm going to go to the second one, movie details 2, and so on. Perfect. That means that now using this ID, we can go ahead and query the details of a movie. I'm not going to bore you with this one. This is the movie details. So we can go ahead and basically copy everything from here. Yeah, let's go ahead and copy the whole component for the movie details screen. because the rest of the things we already know how to do. We know how to use Supabase to query for a movie based on the ID using the .equal operator, the lib Supabase, lib Supabase. What's going on here? Oh, it should be one more, I think, like this. Lib Supabase. That's exactly what we had. Okay, this is the home page. If I go to the Toy Story, yes, it renders the Toy Story. Go back here, it renders it. Perfect. But the last step is to play a little bit with the themes. Because right now, the navigation part of our application is still working with light themes, but we can adjust that in the layout here by using the theme provider from where? Not from where, from React Navigation Native, and also we will use the dark theme. If we go ahead and wrap our stack navigation with the theme provider and the theme, where is it? Value dark theme. We will see that everywhere where we use the theme here, it's rendered with black. So now it works better. Now we have a details page with information about the movie. Later on, we're gonna render the recommendations here for the movie when we implement the AI part in a moment. And yeah, that's everything that we need so far. Additionally, you can also adjust, for example, the headers and the titles using this tag, and by default it will render the name of a file. But if we want to change the title, for example, on the details page from ID to something, to like a movie details, we can use tag.screen. And using the name of a file here, name equal name of a file, which is the ID, we can add React Navigation options as you are used to. For example, we can add a title here saying movie details. So if I'm gonna go here, we see movie details. We can do the same for the first screen, for the index. But for the index, what we can do is we can say header shown false. And this will hide the header from the first screen. Perfect. I think that's everything that we need for now as the layout of our application. So what we have is the home screen that renders a list of movies, and the detail screen where we can get by pressing on one of these movies, and it will display the information about the movie. For example, besides the tagline, we can also render here the overview. So overview like this to see more information about the movie. Yeah, and we can even add some styles here to the overview. Color, I don't know, Gainsborough, and maybe margin top 20. I'm focusing on very small things, but we are basically done. We need to. So if we go to different movies, we're gonna see the information about the movies, more details about it. Yeah, something like this. And later, we're gonna have a text here saying similar movies that will render a list of similar movies. Similar. I can style it very similar to our title, but I'm gonna also add, I don't know, margin top 20. So that's our front-end side. I'm gonna go ahead and do a git add here. Expo router and movie details page. And I'm going to include in the source code the code for at this step. So that you can take it from here and focus on the AI part, because that's the focus of today's tutorial, and we are finally at the point to implement the AI features in our application here. Actually, I want to do one more thing. On the home screen, I want to add a search input, not to waste time on it later. So that's gonna be quite easy, but let's do it now, and so that you will also have it there. What I'm gonna do is above a flat list, I'm going to render a text input. Make sure that it's imported from React Native, like this. Now the text input will have a placeholder saying, I don't know, AI, what are you? Search for movies. The placeholder text color can be gray. Yes. And I'm gonna add some styles.input. Let's go ahead and add these styles here for the input. I'm gonna start with border width 1 and border color of gray. I'm gonna add some padding like 10 or even 15, and maybe some margin 10, and some border radius to make it round 10. Yeah, 10 I think is good, or 5. No, let's go with 10. Okay, and the last step is to bind this text input to a state variable to be able to use to know what the user is searching. So I'm gonna use it as a query, set query, or prompt, and initially it's gonna be an empty string. Now all we have to do is to assign the value to our text input, the value of our query, and when the user changes on change text, we want to update the state, set query. Just like that, we're going to be able to ask and search for queries. I need to make sure to change the color to Gainsborough here. Yes. And we also need a button, right? So if I will simply add here a button from React Native, let's go ahead and give it a title, search, and that's how it looks on iOS. We can also put them into the same line, not to use so much vertical space, by wrapping them inside a view. And if we give the style justify content, not justify content, but flex direction row, they will put it into the same row, and we can also say what? For the text input, I will say flex 1 to make sure that it takes all the space available. And on this view, I can align items in the center to make sure everything is centered. Okay, now we're good. And probably if you also want to do, like, the last step would be the onPress function that will be executed when we press on the actual onPress. For now, we can reset the query to empty string, and later we're gonna use this. So if you assign the onPress to the onPress here, we can write something, press search, and it should remove. And later it should actually call a method on our backend to get semantic search and recommendation based on the prompt that the user writes. So it's not gonna work like specifically about using the like titles and description. It's going to understand the meaning of what you're writing and will try to recommend the best movies for that. So yeah, it's gonna be fun. Like, give me just 1 second and we will implement that. All right, so let me not forget to do git add, git commit, search input. All right, so this is, we're done with setting everything up. We have created our Supabase project. We created our database there. We added a data set of movies. Then on the client side, we implemented our React Native application that is able to query the data about movies from our database, render it in a visually pleasing list, and now everything is ready for us to implement the AI features that we all came for. So let's go ahead and look at what tools we're gonna use to implement that. So for a disclaimer, I'm no expert in AI and so on. I was invited by Supabase to participate in their content storm for the AI and vector database, and I was very excited to learn more about that. And I was pretty impressed by how easy it is to generate embeddings and to implement these AI features using them, using the Supabase Vector to store it. So I will try to make it as easy as possible for you as well. I will explain things the way I understood them and all the things that we need to know. And I think it's gonna be easy for you to understand because I'm somewhere close to you and it's gonna make a lot of sense. What are everything that we need in order to make this possible? So let's go ahead in our guide. And first of all, yeah, let's go ahead and open the documentation. Where is it? All the vector columns here. So we're gonna use the AI and vectors from Supabase, and from their documentation, what this is a toolkit with a lot of useful tools for us to implement AI features. The one that we're gonna use is this vector store that basically allows us to store vectors directly in Postgres, not only store them, but also query them. Now, what are vectors? Let me actually open the some diagramming to try to make this one easier for you to understand. Come on, how to do a new one? Delete everything. So first of all, yeah, like basically what are vectors? Vectors, when you first look at them, they look like an array of numbers. For example, we have like, I don't know, 0.5, then let's say 0.7. This one looks like an array of numbers, but what makes it a vector is the operations that we can perform on it. So this is actually a representation in space of a vector. For example, this one in particular, because it has two numbers, is a two-dimensional vector, and it can be visualized on a graph if we draw it like this. So this is y-axis, this is x-axis, and if here is 1 and also here is 1, this point will be, if this is, for example, the x representation and this is y, this is going to be 0.5 somewhere here, y 0.7, let's say here. So this is our dot, 0.5, 0.7. Now this is a very simple vector with 2 dimensions. You can also visualize a 3D dimensional vector like this, where there will be one more value here if I erase this one. For example, you'll be able to visualize that. 0.8. Yeah, probably I cannot draw it, but yeah, basically you can map it, visualize it. It's very hard when we increase this amount of dimensions to visualize that, but at the end of the day, think about vectors as a way to represent in space, like, yeah, basically vectors. Now, the part where AI is using vectors is the vector operations like cosinus and so on. And this will help us define like how close are 2 points to each other. So the representation of 2 points, this one is, for example, 1.2, 0.3, and so on. I'm going to stick to 2-dimensional vectors for now. And yeah, basically, based on some math operations that I didn't have time to look into, and I don't remember from my math classes, we can define basically the difference or the distance between these 2 vectors by knowing their coordinates. This is helpful in the next scenario. Let's go back to our documentation, and slowly we're going to understand everything that we have to understand. The second part, yeah, let's go to the concepts. And a very important concept for us to understand is the embeddings. What are the embeddings in the context of AI? Because they are used a lot to power AI and vector applications. And in general, embeddings is a way to represent any data as a vector. So let's say we have a text. Computers do not understand the meaning of a text. They understand characters, but they cannot put them together to understand the meaning. So by using a machine learning model, we can generate a vector that represents the meaning of a text. For us, this vector doesn't tell us a lot, but with having 2 of these vectors, we can use some math calculations to find how similar are 2 different texts from each other. And this is actually what embeddings are helping us do. They capture the relatedness, like how related are 2 pieces of information, like texts, images, videos, or any other type of information. And this relatedness is very useful when we have to implement semantic search. For example, when a user writes something, we can go through all of that data in our database through their embeddings and see which embedding is closer with the meaning and the context to what user is searching. Exactly that we're going to implement a little bit later. We can also implement recommendations using these embeddings, because we can take the embeddings of two products or of two items in our database and see how related are they to each other. And for recommendation, we're going to sort by the most related items, and we're going to recommend that. Classification is how to categorize a body of text. For example, you can create, using a machine learning that is trained to understand if an email is spam or not, we can generate embeddings and we can classify them. We can see visually, let me try to show you that. I'm gonna again keep it very simple, and let's say that we have a two-dimensional vector for our embeddings. And let's say we're developing, here I'm explaining probably the classification. Let's say that we train a model that knows that anything that, is here, this is spam. And anything that is here, this is not spam. And anything in between, it's gonna be like, how spammy is it, right? So now, if we have a body of text like an email, and we generate the embedding using the same embeddings that we trained our machine learning model here, we can plot it here. So for example, an email that will have a vector somewhere here, it's going to be unclear if it's spam or not. If it's going to be here, for example, 1 and 1, we can say that this is classified as spam. If it's going to be here, we can understand that it's not spam. And again, this is a very simple representation with 2 dimensions. In reality, our vectors contain a lot more because they need to keep track of a lot more information to be able to categorize them correctly. So here is a very good example for understanding embeddings better. For example, let's say we have 3 phrases. The cat chases a mouse, the kitten hunts rodents, and I like ham sandwiches. Our goal is to try to understand what are the similar phrases from these 3 phrases. We, as a human, for us, it's very easy to understand because we can understand that cat and kitten is basically the same, chases and hunts is the same, mouse and rodents is the same. But for a machine, for a computer, these 2 are completely 2 different phrases because the only word that is repeating in these 2 phrases is the. Everything else is different. So using embeddings, we can basically capture the meaning of the phrases, not the actual words. And by generating the embeddings and trying to see the similarity between these 2, we will find that they are very close to each other and they will be quite far from I like ham sandwiches. So yeah, basically this is the explanation here as well. If we plot the vector of our embeddings for these 2 texts, we can see that they are quite close to each other and the other one is quite far away. So another thing is, for this project that we're gonna use, we are going to use a model called GTE Small, developed by Supabase, that produces an output of 384 dimensions. Might sound a lot, but I think ChatGPT has way more. I mean, the models behind ChatGPT from OpenAI has way more. And but yeah, for our example, 384 is going to be more than enough dimensions to provide very useful information. So yeah, that's our embeddings. I hope I made it a little bit more clear the way I understood them. And with the vector columns, with the vector extension from Supabase, what we can do is we can store these vectors that we talked about. We can store them directly in our database, and then we can query. We can query them using operations like Euclidean distance, negative inner product, and cosine distance. To be honest, I still don't understand them very well, but depending on different scenarios, we would use different operation. Basically, this operation is helping us understand, this is a way to understand how close are like the vectors from each other. And it uses different operations, like math operations. For us, it's going to be very easy. So I think we are done with the theory side. Let's go ahead and implement it, and we will try to understand them better as we use them and implement them. All right. So the first step is to go ahead and set up the vector extension and the vector column on our movie database to be able to store embeddings about movies directly in the database. To do that, where is it? This is our project. I'm gonna go ahead in our AI movies. And let's go ahead in the table editor. Is it in the table editor, or where do we enable extensions? Table, no, yeah, not on the table editor, but down below to the database. Here under the database, there are extensions. Let's go to the extensions. And the extension that we are interested in is in the vector. It's called vector. And as we can see, this allows vector data type inside our table. So let's confirm and enable the extension. And after that, we can go back to our tables. And in future, it's going to be possible to simply edit the table, add here a new column embedding, and select from here the embedding data type. The problem is that at this moment, it's not yet possible, but as I talked with Supabase, it's coming in future, I hope. What we can do is we can add this column using this column embedding using the vector type. We can add it directly through SQL editor. So let's go ahead and copy this command from our guide. And it simply is the command alter table movies, which says update the movie table and add a new column there called embedding with the type vector. And inside here, we specify how many dimensions will the model produce. So we are choosing 384 here because we are going to use the GTA small model from Supabase. And as you can see, this one produces dimensions GTA small 384. For example, here is, no, where is it? Yeah. Anyway, if you're gonna use another model to generate embeddings, for example, for images, if you have to process images or text or some other things, you're gonna need a different model to generate embeddings. In a moment, I'm going to show you how you can explore them, how you can choose from them. But the important part is to know how many dimensions the model will generate and use that here in the vector. So after we have this one, let's press run here. And we see success. If we go back to the table editor, if we select movies, and if you scroll all the way to the right, at the end, we should see the embedding column of type vector. And here we're going to be able to store the vector embedding of our movie, and based on it, implement the AI recommendations. So the next step for us is going to be to generate embeddings. We're going to use transformer.js, which is a tool to use open source models, and it's really easy to use. As you can see, we basically need a couple of lines of code to import the pipeline, to define what model do we want to use, and then to send some text to the pipe in order to get the embedding. What we will do is, first we're going to see how we can generate embeddings locally in a simple notJust server, in order not to confuse you with edge functions and so on, but later we're going to also generate them in the cloud, on edge, in edge functions. But anyway, what we have to do now is let's for a moment leave aside our React Native project, and let's go ahead and create a new empty directory. I'm going to navigate somewhere also there, projects. Or should I do it? Let me navigate to Netflix. I'm actually going to generate this folder inside our React Native project just for everyone to have a source code of it. But you don't have to. This is going to be a separate project that we can create in a new project. So I'm going to create this folder called, how to call it? Embeddings. Let's call it embeddings. Let's navigate to this folder, embeddings. And here, let's set up an empty notJust project. To do that, we can simply run npm init -y. This will generate our package, and we are ready to go. I'm gonna go back actually to our VS Code here. Where is it? As I said, I ended up initializing it inside our project. Oh, 1 second, where is it? AI movies, here. This is our project embeddings, but it has its own package.json. So if I open a terminal from our Visual Studio Code, it will open in the root directory of AI movies. I would have to go to embeddings in order to be able to install and work with the specific project there. So once we are here, we are ready to install the transformer.js. And to do that, we're going to use npm i xenova/transformers. And after that is installed, let's go ahead and create a new file in our embeddings called generate embedding dot. I'm going to keep it JS here. We're going to import pipeline from Xenova transformers. And because we are not implementing this inside browser, using the env, I can say env dot use browser cache equal false. Usually these transformers can run in browser, but we're gonna run them inside notJust context. Now we should define our pipe, and the pipe is all the models through which we want to send our text, and in the end to get a vector. So we can stack together multiple models, and all of them, like the data that we will give it to our transformer, will go through all the models, and at the end will simply give us a vector. Why is this helpful? Because there are different models, more generic one, for example, understanding syllables or understanding words, will be at the beginning, and at the end there will be more specific models. Basically, once we understand words, we can understand sentences, we can understand meanings, we can understand if it's spam or not. So the pipeline that we are going to initialize it with is going to be, first of all, feature extraction. And the second one is going to be the model that I was talking about, the GTA, actually it's called Supabase /GTE small. These models, they are hosted on Hugging Face. So you can search Hugging Face for other models that you might need. For example, here under the models, you can look for others. Supabase, for example, this one is GTA small. There can be others as well. For example, Stable Diffusion. Anyway, having this pipe, let's go ahead and generate a separate function now that will generate embedding. And this function will simply receive a body of text, we'll send it to our pipe, and we'll return what it gives us back. So let's get the output by calling await pipe. And here we're gonna send, first of all, the text, and then some arguments. One of the arguments that we're gonna send, I'm gonna take them from here because it's pooling and normalized. I don't know what pooling means, but normalized means that give me a vector that is of length of 1. So this is the normalization. And what we're gonna do is we're going to generate an array from our output dot data. It's as simple as this one to generate an embedding. And what I can do is I can call this generate embedding with hello world here. And we can actually do a wait. And after that, console log to see the response. We can execute this function by writing node generate embedding, but make sure you are in this embeddings folder. We cannot use import statement outside of a module. So in package.json, we need to change it to a mod. Where is it? Come on. 1 second. Yeah, basically what we have to do, if we want to use the import from statement, in the package.json, somewhere here we need to define the type of this project is module, not common.js. And now if I'm gonna run the embedding once again, the first time it will download the model, so that's why it took a little bit more time. And at the end, we're gonna see an array, which we learn that it's not an array, it's a vector. And this vector contains 384 numbers, specifying the, basically the embedding of our hello world text. For us, it doesn't say a lot, but for the computer, it empowers it to find similarities between things. And if I'm gonna do it again, as you can see, the second time is much faster because it already cached this module, feature extractions and the GTA small. All right, so what we should do now and what we will do now is go ahead and for all the movies in our database, we're gonna generate the embedding based on the overview and save it in the database, back in the database. So let's do that also in this embeddings folder. And where will we do that? Well, let's create a new file here called update movie embeddings.js. The first function that we will need here is to get, first of all, a list of movies from our Supabase. And for that, we will need the Supabase client. So let's go ahead and, because this is a separate project, I'm going to actually create a Supabase.js file here. And from our source directory, from our React Native, I can take the client, the way we set up the client here, I can take it and move it to the Supabase.js. But the only thing is that we don't need the authentication here. I can delete this one. I can delete the whole options thing. I don't need async storage. I don't need the first polyfill. I only need to create the client. And probably I will also use not a non key, which is anonymous. I will use the master key that will allow me to do different modifications on the table. So Supabase key. Let me take it from. Let me show you how we can take it. This is important because we want to update something in the database, and either we add a new policy here to allow anyone to run updates, or we can use a master key that will allow us to do anything. So let's go ahead in the project settings, in the API. This is a service role. This is a secret. And because we are not using actually it in a client side, it's okay to use it on the backend. We're never gonna post this embeddings file anywhere. So let's put it here. Now the Supabase will allow us to do any kind of operations. Back to our generate embeddings, update movie embeddings. Let's go ahead and import Supabase from Supabase. From .supabase. I think we also need to install the Supabase client here in the dependencies. So again, make sure you are in the embeddings folder, and let's run npm I Supabase/gs. Let me see how it's called. No, it's at Supabase/Supabase JS like this. Now in the package, besides the transformers, we should also have a Supabase JS. Okay, perfect. And in the get movies, what we can do is basically return supabase.from our movies. We want to select all the columns. You can actually select only like ID and overview, but yeah. And we can also add a filtering to make sure that we only select the ones that do not have an embedding. Embedding null. Now we can go ahead and do movies equal get movies. Let's await. Actually, this will return us data. And let's go ahead and console log to see if we actually receive something. So I'm going to console log movies.length. If I run the update, where is it? Update movie, node, update, movie embeddings. We're going to see what? Cannot find module. Which one? Update movie embeddings. Import Supabase JS. Do I need to specify JS here? Yeah. Import Supabase. I need to destructure it. And just like that, we have 1000 rows because that's the limit of how many items Supabase will return from the server. So for that reason, we're gonna have to query them multiple times. That's why we added this. Get me only the one that do not have an embedding. Let's actually define this process all movies, which is an async function. Come on. And I'm gonna add it here and simply call at the end process all movies. And this way, if I run it again, we should see 1000. Yes. Now, besides process all movies, I'm gonna add another one on top here that will add movie embedding. It's going to be a sync, and it will receive a movie, and it will go ahead and update it. But before updating it, let's generate the embedding. We already know how to do that. We have this generate embedding in the file. We can export this function, and we should make sure to delete the last line here. We don't need this anymore. Now that we are exporting the generate embedding, we can import it in our file that we are working in. And we can do await generate embedding. And because the generate embedding expects a body of text as a parameter, we're going to take the movie overview and based on it generate a vector embedding overview. Let's do console log embedding. And in order not to overflow our console, in the get movies, we can go ahead and do a range 0 to 3 to limit only to 3 movies. Now we have this add embedding, but we never call it. We should call it based on the movies that we receive here. We can actually check if movies.length is not defined with question mark. That means that it's either an error or there are no movies yet. So we can stop here. Otherwise, for every single movie, I want to call this function. So that means that I will have to map through the movies. And for all of them, I will call the add movie embedding. because this is an async function, the movies.map will give us back an array of promises. So what we can do is we can put them inside a promise.all, like this, and run them in parallel. Basically, like execute all the add movie embeddings on all the movies, and only after you're done, like finish it and go to the next line. So now let's go ahead and run it again. And what we should see is, we don't have a generate embeddings because we need to import generate embedding from generate embeddings.js. Now, if I execute this one, we should see 3 vectors. 1, 2, 3, 4 actually, because it's 0 to 4. These are the embeddings, the vectors that we created based on the description of a movie. Now, based on these vectors, we will be able to find similar movies between them. But before we do that, we need to save this embedding in the database to be able to later do these queries. At the moment, all of them are null. So to update it, it's quite simple. We're gonna also use Supabase from movies. We want to update and set a new field embedding with a value embedding, where the to only movie where the ID is equal to movie.id. So don't update it to all of the movies, only to the one that we currently want to update. And just like that, if I will run it again, we don't see any errors. And if I'm gonna go here and sort, maybe not sort, but execute a query like this, select everything from movies where embedding is not null. Let's see if we're gonna receive anything. Yes, we see Jumanji, GoldenEye, and Toy Story. If I'm gonna execute this command again, I'm gonna remove a console log. If I'm gonna execute it again and run this query again, we should see already 8 results. The next ones were generated. And at the end, you see the vector embedding. Maybe you don't see it because I blocked the view, but it's here. So let's do the following. We know that we generate them correctly. We save them correctly. Now we can remove this range from here. And if I execute, it will add to 1000 at the same time. In this process all movies, I can go ahead and at the end, basically right now if I execute, it's only gonna add it to 1000 movies. So if we have 40K, I'm gonna have to execute this process 40 times. If I want instead to process all the movies from the database, I can call at the end here, process all movies again, which is recursively calling it. And because this is very important, because we have a stop condition here, it's only going to call again and again until there are movies without embeddings. And after that, it will stop. If I execute it now, it's gonna take a bit of time. We see first 1000 movies being processed. We're gonna wait a bit. Then we're gonna see another 1000, another 1000 until all the movies from our database are processed and have their embeddings. This shouldn't take quite a lot. It should probably take around 30 seconds. Let's see it in action. Guys, if you have any questions, please ask me, and I'm gonna try to explain them the way I understand. And let me know how is it going so far. Did I confuse you too much, or do you have the same feeling as I have that it's actually not that complicated? Like all of these things, I thought that they should be so much more complicated. But generating embeddings, look at this file. It's one line to create this pipeline by selecting the models that we want, and another one to pass a text and get the vector, the embedding. That's it. So yeah, we are building on top of the shoulders of giants. Basically, companies like Supabase that created all of these features that are easy to integrate, and other companies that are investing a lot in the AI tools, like they are helping us do that. Because yeah, I remember a couple of years ago when I was in university, I took an AI course and it was much more complicated. But at that time, like we learned the fundamentals of it. So yeah, sounds complicated, but in fact, if you know what tools to use, it's actually very, very possible. And if we look our script updated 1,000, 2,000, 2,500 movies. And if I actually do it again, we see that it will not do it again because we have this condition to only add the embeddings when the embedding is null. So if I go now to our database here for the movies, you're gonna see that all the movies should have this vector here. Vector with the embedding. We are getting there. So far, we learned about vectors, embeddings. We set up a vector column for our movies in the database. And locally in Node.js, we generated the embeddings using transform.js. We save these vectors in our database. And what this allows us to do next is to run queries on our database to give us, for example, similar movies to a movie that you already watched. That's going to be possible to do. Let's actually see that in action and move on to the next step. And also, we're going to be able to later do semantic search, basically writing a sentence and based on that sentence, trying to recommend movies that are related to it. To do that, what do we have to do? Let's see our guide. Again, all the code you'll find here. Getting similar movies. Let's open the documentation. Besides our guide, we're also going to look in the documentation for the vector columns. And here we already have done and stored and so on. But at the part of querying a vector, here is where we are at right now. What we have to do is to query these vectors and be able to find similarities. There are 3 supported operators at the moment, as I was talking before. The one that we are going to use is the cosine distance. The thing is that the Supabase client library does not yet support these operators. So if I'm gonna go here, give me just 1 second, I will do git add. So if we look at our application index here, the Supabase client, Supabase just client here, we can provide, like, for example, where the title is equal to Jumanji. This operation is possible, but operations on vectors, which are these 3 operations, they're not yet supported. So what we have to do is we have to simply create a function on the database layer with Postgres that's quite easy to do. And using this RPC method, we're going to be able to call that function. Let's go ahead and take the code of this function from here and go to our AI movies. Actually, it's going to be better if you take the one from our documentation because I updated it specifically for our needs. Let's take it from the documentation, go to our AI movies, go to the database, and here you'll find functions. In these functions, we can create functions that will run on the database layer. These are not Lambda or Edge functions. These are functions on the database. The name of a function, how did we call it? Match movies. Match movies. Schema public, it's okay. Return type void. Wait a second. No. This is the visual way of creating a function. You can do that for here as well, but because I prepared the SQL statement, let's press cancel, and we're gonna create that function through code, not visually. To do that, open the SQL editor in the left menu, and let's paste the code from our guide. I'm gonna explain it simply. It's defining a function called match documents. And I failed to copy it correctly because it should be match movies. Copy. Back here. Yes, now it looks better. So we're creating a function called match movies that will receive three parameters. A vector with which we want to compare, the match threshold, and the match count. How many items should we return, and what is the threshold that we should consider that the item is related? We return back and kind of a new table, a virtual table, that will have an ID, a title, tagline, overview, and the similarity score. Now, the logic of how we get the data is here. So first, we select the information from our movie database, like ID, title, tagline, and overview. Now, here is where we see our vector operation. This is the vector operation from our database. That is the cosine distance. So what we are doing here is we are getting the cosine distance as the similarity between the movie embedding from the database and the one that we are sending. So it compares, it returns a similarity, which is going to be a value from 0 to 1, where 1 is a very similar movie, 0 is completely opposite. Later, we are simply we are excluding movies from the list that will be returned. We are excluding the ones that have a lower similarity than the threshold, and only keeping the ones that are very similar. Then we are sorting the table based on the similarity that was calculated here, and we are returning only the amount of items that we will send through parameters. So this is our function. Let's run. It's running, and we should see success here at the end. Now, after we have created this function, and I created the function based on this example, we can execute the function using the Supabase client by calling this RPC. If I go back here, let's actually take this code from the Supabase documentation. Let's go back to our React application. And what should we do? Let's first implement similar movies. So if we go into the details of a movie here, we have a fetch movie, and that means that if I do console log here movie.embedding, we should also have the vector where is our simulator? If I go to the Jumanji here, we should also have a vector based on which we can find similar movies. So use effect here. Let's go ahead and define here a similar movie state. And in another use effect, after we fetch the movie, let's add another use effect that will fetch similar movies. When should that happen? That should happen when the movie dot and question mark dot embedding changes. Only then we should retry to fetch similar movies. Let's define the const fetch similar movies equal async. It's going to be an async function that we will call right away. Now, in this, probably we should also check if movie.embedding is null. Then we should not do anything. We're gonna return. Now instead of a function fetch similar movies, what we have to do is we have to call our newly created function called match movies. If we go to the database functions, we should see this function in this list. The name is match movies, these are the arguments, and this is the return type. Based on the documentation, we see that to execute the function, we're going to use the RPC, which is remote procedure something, controller maybe, I don't know. And yeah, we can execute it this way. Let's take the code, use it in fetch similar movies. In our case, it's not Supabase client, it's simply Supabase. That will be imported from our lib Supabase. Match documents. The name of our function was match movies. So let's replace this one here. The query embed, the vector on which we want to find similar movies is going to be movie.embedding. Yes, pass the embedding you want to compare. Choose an appropriate threshold. I'm going to leave it like this. Maybe we can test it later. And choose the number of matches. Let's go with less. Let's go with 5. And here, because we have similar movies, let's console log similar movies. If I go to Jumanji, it's null. It's null. But why? Oh, because we are not doing anything with the data. Yes, we need to set similar movies with, let's call them similar movies. Or let's leave it as data. We don't care really much here. I'm gonna set them in state. Okay, now we see some information here with similar movies. What we can do is use these similar movies together with a flat list and render them on our screen. The data is going to be similar movies, and render item is going to be our movie item. So if I go to Jumanji here, we see similar movies. The first one is Jumanji because this is the most similar one with this one, which is actually true. Then Peter Pan, A Space Adventure, and so on. Why do we have only one here? What happened with all the movies? In the index, what happened? Oh, because we have equal title. I don't want this anymore. So if we go to which one? Mortal Kombat. Similar movies. Mortal Kombat, Conan the Barbarian, Rise of the Guardians, Pacific Rim, and Golden Army. To be honest, I'm not very familiar with movies, especially old ones. I barely watched any movies in my lifetime. So I don't know if what it recommends is actually true. But it looks like it. The Mask, From Zero to Hero. Ghost, The Great Mouse Detective, The Frighteners, The Do-Over. And the way it works is basically on this overview. We are not including the title or the tagline or the genre or anything else. We are only generating embeddings on the overview, the text that describes the movie. So it tries to find our movie with an overview that has a very similar meaning. So that's how it works. If you want to include the title, you can also do that. You can have multiple embedding columns for the overview, for the title, and then generate them separately, or you can combine them together into the same string. That's also possible. Ghost, Drag Me to Hell, Are You Here, Push, 12 rounds. I think it makes sense. And if I go from Ghost, that recommends me Drag Me to Hell. If I go to Drag Me to Hell, can I go there? Why it's not going there? Oh, I know why. Because it stays on the same page, ID, and in the first use effect, where we query for the user, we only do that once, but we should do it every time the ID changes. So I will put the ID in the use effect here. So Drag Me to Hell. The Ghost is the third one. 50 Shades Darker. 50 Shades Darker, 50 Shades of Grey, Drag Me to Hell. I'm not sure if they are exactly the same genre, but based on the overview, they should have similarities. Perfect. So our similar movie recommendation is already working based on our generated embeddings that we save in the Supabase Vector database. Nice. So the next step that we're going to do is be able to provide a semantic search here, also based on embedding. So if I will ask a movie about assassins, it should return me like probably the second movie, Assassins. I would expect so, because it will try to understand the meaning of my sentence and will find the movie which overview is closest in meaning to the value of a string that I'm searching. Whew, okay. I hope you are still managing to follow it along. And yeah, we can move on. And by the way, guys, if you enjoyed it so far, and if you haven't already, make sure to subscribe to our channel. We are trying to reach 100K by the end of a year, and it will mean a lot to us if you help us get there. Thank you, and yes, let's move on to our last step for the semantic search. The challenge with a semantic search right now is that when we write something, this is still text. To get similar movies, we need a vector, we need an embedding. So the similarities between movies, we found it because we already have this in our database. But what the user is writing, it's still not embedded. We need to put it through the same models. It's very important to use the same models, generate the embedding, and only after that query our database for movies that are similar to our query. Let's remind ourselves how we generated embeddings. We generated them locally in a notJust context. We cannot basically our application will run on users' devices. So it either has to generate embedding directly on the user device, or it should send a request to an API to do that on the backend side based on a text or based on a body of text to give us back the embedding. This local one is not going to help us. I was thinking that it might be possible to generate these embeddings directly on our mobile device. And because React Native is using Hermes as the JavaScript engine, I'm not really sure if that's possible. If you know a way to run transformer.js in the context of React Native, that would help this project a lot because we can generate embedding right away on the device. In our case, what we're going to do is we're going to create an edge function using Supabase, which is a simple function that will be executed in the cloud. And we can invoke this function from our client side. We can send a text. That function will generate the embedding in the backend where it can use the transformer.js and will give us back the vector, which we can use to later query the database. So this is actually a great way to see how we can also generate embedding on the edge, in the edge function. If we go to the Supabase documentation, under the JavaScript example generate embeddings, here we will see the documentation for the edge function features. We already have a Supabase initialized. What we want to do is we want to add a new function called embed. Let's go ahead in our project. In a new terminal. Make sure that now we are not in the embeddings folder. Make sure we are in the root directory of our project. If I do ls, I should see the, for example, app.json and the Supabase directory. Now I'm going to go ahead and initialize a new edge function using Supabase. How's the syntax? Functions, new, functions, new, and we're going to call it embed. What that has done was generated a new function in the Supabase functions here called embed, and you should find it here with the index.ts. This function is a Deno function, very similar to Node.js, but yeah, we're gonna be able to reuse some of the stuff that we already know. Let's go ahead and import, or let's copy everything, come back, and at the top, instead of this import serve, actually I'm gonna leave it because maybe it's the new one, but it's the same. I'm gonna simply paste what we copied, and here what we imported is the pipeline from the transformer.js. In Deno, we don't need to install packages. We can provide directly the URL and it will take it from there. But it's the same as we saw previously. We are using transformer.js. We take the pipeline and environment. We are adjusting a little bit this environment to say that this is not a browser. I'm going to delete this console log. I don't need it. And inside serve, we're going to, no, first of all, outside serve, I want to create the pipeline with the models that we want. Here, if I take it, it's the same pipeline that we use. And it's important to use here the same pipeline as we have used to generate embeddings for our data, for our movies. And if you look in the embeddings, generate here, we see that we also used feature extraction and GTA small. Feature extraction, GTA small. Perfect. Now that we have this pipe, we can go ahead and based on the input inside the serve function, we can generate. Basically, I'm going to copy the whole function here and replace it with myserve. So what it does, it takes the input from the request, it runs it through the pipe, it generates the embedding, and it returns it as a response. Now we can go ahead and run our function if you have set up Supabase locally. If not, we will be able to push it. Actually, yeah, let's not run it locally. Let's right away do npx Supabase push Supabase. There is no push. Let's see the documentation of edge functions. How to push the changes? Oh, functions deploy. Supabase functions deploy. Or maybe npx Supabase. Let's do functions deploy. It's building our function. Deploying function embed on our project. And if we go to our project dashboard under edge functions, we should see this embed function with details about it and command line access. I don't think we need it. But yeah, the function was generated, was deployed, and it's ready for us to send request. For example, this is the endpoint URL. I think if we, not sure if it's gonna be, if it's missing, no, yeah, it needs authorization header. Last step is to call the function from our JavaScript side. And if I have a look at functions, invoke, embed, body, input. Okay. So now our function is deployed. What we have to do is, based on the data that the user will write here, we need to call the function and send the data as the input, and back we will receive the embedding. Let's have a look at how we can do that. Inside our source application index.tsx, we have this information in the query. And when the user presses this search field, what we have to do is to generate the embedding first. So what I'm going to do is I'm going to use supabase.functions.invoke. I'm going to send the name of a function embed. And the second one is the options. So what we need there is the body with our input. And the input to that function will be the data that the user writes from our state variable, the query. Let's get back, I don't know, response, and let's try to console log response. Now I'm gonna look in the DevTools here. If I write something hello, search, is anything? Yes, as you can see, we get back the vector. And the vector is in the data embedding. So I can take the data from here, and the data.embedding will be the data that I'm looking for. What can we do with this embedding? We can do the same thing as we did with similarities. We can send a request to the database to give me movies that are the closest to what the user is writing. So in the ID, we saw that we have done that by invoking the RPC, the remote procedure, the database function called match movies. Let's copy this one here as well. Back in our index.tsx, and we are going to, let's say, match movies. For the query embedding is going to be this data embedding that we get back from for invoking our function. There is a threshold, match count. It can be even more, like 20. And at the end, what we're gonna do is we're gonna update the set movies in the state with the, is it movies here? I hope so. Movies. Let's see. If I write here, I don't know, Titanic and search, we see the first one, actually Titanic. The second one and the others, like triangle, is also something about ocean, Atlantic Ocean, and that's why it's quite similar to what we are searching here with Titanic. You can ask it even like questions like, I don't know, movies for the first date. Yeah, probably that's good. That's already something. And it works based on, yeah, as I said before, it takes what the user is typing as text. Horror. It takes what the user is writing. It uses a machine learning model to transform the text into an array of numbers, which is the vector, the embedding. And then when we press search, it looks for movies closer to that embedding. So we see Halloween. If I look at the Halloween, we see Scream, Facing the Crowd, The Cell, and so on. So that's how simple it is to implement AI movie recommendation based on embeddings. If anyone counted how many times did I say embedding in this tutorial, let me know in the comments below. It should be quite a lot. But yeah, I'm pretty excited about this project. I think that's everything that I wanted to show you today. You can take these concepts to the next level. You can generate embedding for multiple fields. For example, a separate embedding for the title, the genre, the tagline, and so on, where you can put them together in order to have a more holistic overview of a movie. At the moment, we're only doing that based on the overview, but you can include way more information there. Something that you might even consider is taking user reviews, basically what users said under a movie, and generate embeddings based on that, and then search based on what user is looking for. Because at the moment, I'm not sure, but the way I understand, like if I say here, recommend a movie for the first date, it's going to find basically movies where there is date or couples or love in the overview. It's not actually knowing like what is a movie for the first date. It's going to find like only, yeah, basically movies similar to the words that we wrote here. But if we take, for example, user reviews, in the user reviews, usually people write like, oh, I watched this with my girlfriend at my first date and it was a nice movie. And that would be a better way of matching the meaning and the context and the similarity between the intent of what is the user is searching with the movie that we want to recommend. But again, this is just the beginning. I showed you the embeddings and building the knowledge database using a movie data set, but you can do this with any scenario. basically every data that you have in an application. If you have, let's say, a blog or the documentation of a tool, what you can do is generate embedding of all the pages of your website or tool or application, and then provide an AI search box that user can type something, and using embeddings you can find the article, the page, the blog, the feature that is similar to what the user is searching based on comparing their embeddings, and recommend that to them. This is a very powerful search feature. You can also implement recommendations like similar blog posts, similar items. In e-commerce, you can generate similar products. Yeah, I don't know. Sky is the limit. Let me know what you're gonna use this for, and I'm really curious about that. Once again, thank you very much, Supabase, for sponsoring this video. It was a pleasure for me to dive more into the AI, and I think that this is just the beginning. I would really love to do more tutorials about AI, because it's so powerful yet quite simple to implement with all the tools that are out there. If you're interested in more AI tutorials, let me know in the description below. And thank you very much for watching this till the end. If you'd subscribe, I would appreciate that. We're trying to reach 100K. And I'm not only asking you, I'm doing something on my own. I'm trying to do more tutorials. So if you're interested in learning and becoming a better developer, you're gonna enjoy what we have prepared for the next couple of months. All right, guys, have a nice rest of the day. Bye-bye, and I'm just gonna see you in the next one. Have a nice day.